What if you could pull the plug on the entire Mediterranean Sea with nothing more than a kitchen sink drain? Sounds ridiculous, right? But let's actually run the numbers. In today's video, we're going to put the Mediterranean, all 3.7 million cubic kilometers of it, up against one ordinary sink. We'll look at how long it would take to drain, what physics would sabotage the process, and why your sink might actually rip itself apart before the sea level even drops an inch. This is one of those ideas that sounds like a cartoon, but turns into a deep dive into fluid mechanics, energy loss, and some very real engineering nightmares. So, grab your wrench. We're pulling the plug. How much water are we talking? About? The Mediterranean Sea holds about 3.7 million cubic kilometers of water. To picture that, it's 1,000 times larger than Lake Superior, and if you spread it evenly, it would cover the entire Earth in a 10-meter deep ocean. That's the amount of liquid you're trying to send through a hole in your sink. Even before physics shows up, it's a mismatch of absurd proportions. Example for viewers. Imagine trying to empty an Olympic swimming pool with a straw. Now multiply that problem by a few billion, and you've got the Mediterranean versus the sink. The sink drain capacity. Okay, let's size our sink. A typical kitchen drain is about 5 centimeters in diameter. With perfect flow, water could exit at roughly 3 liters per second. That's decent for rinsing pasta, but draining a sea? Not so much. At that rate, emptying the Mediterranean would take, get this, over 39 trillion years. That's longer than the age of the universe, several thousand times over. Your sink would finish its job long after the sun has burned out, and Earth is just a rock. Visual cue idea. Show a sink slowly dripping while cosmic time-lapse races, stars forming, galaxies colliding, Earth frozen, head loss and flow restrictions. But wait, it's worse. In reality, you don't get perfect flow. The longer the pipe, the more friction you lose along the way. Engineers call this head loss. Add in bends, roughness, and pressure differences, and your flow slows dramatically. By the time you account for a pipe long enough to actually reach from the Mediterranean basin through Earth's crust to wherever the water's going, you're talking about a trickle. It wouldn't just be slow. It would be pathetically slow. Cavitation and destruction. Now let's say, for fun, you try to speed it up. The faster water moves, the lower the pressure gets in certain spots. Drop the pressure too much, and the water literally boils into vapor bubbles, even without heating. That's cavitation, and it's the same destructive force that eats away at ship propellers and turbines. In our sink, cavitation would shred the pipe, implode sections of it, and make the whole setup collapse almost immediately. So instead of draining the sea, you just end up with a broken sink and a lot of sad plumbers. So clearly, a regular sink is hopeless. But what if we upgraded? Could we build a sink big enough or a drain wide enough to actually make a dent in the Mediterranean? Super sink scenario. Let's imagine scaling up. Say instead of 5 centimeters, we built a drain the size of the Suez Canal. That's about 300 meters wide, 24 meters deep. Now you're talking real flow. At max capacity, such a drain could theoretically move billions of liters per second. Sounds promising, right? Well, not so fast. The time to empty problem. Even with a drain this size, you're still fighting the staggering volume of the sea. With optimal flow, you might empty the Mediterranean in tens of thousands of years, which is better than trillions, sure, but still longer than human civilization has existed. And that's assuming constant, uninterrupted flow, which physics and geology rarely allow. The pressure at depth. Here's another issue. The Mediterranean isn't flat. At its deepest point, near Greece, it drops to over 5,200 meters. That means the bottom water is under 500 atmospheres of pressure. As water drains, pressure differences would trigger wild currents, turbulence, and possibly collapse sections of the basin floor. Instead of neatly emptying, you might get earthquakes, tsunamis, or geysers of superpressurized water exploding through the pipe. Environmental consequences. And even if you pulled it off, you'd expose an entire seabed that hasn't seen sunlight in millions of years. Coastlines would collapse. Weather patterns across Europe, Africa, and Asia would destabilize. The Mediterranean actually regulates climate. Remove it, and you change rainfall, wind currents, and even the jet stream. You wouldn't just empty a sea. You'd rewrite the planet's weather system. So, can you drain the Mediterranean with a single kitchen sink? Absolutely not. The flow rate is laughably small. The physics of head loss cripple you, and cavitation would shred your plumbing before you made any progress. Even a mega drain the size of a canal would take thousands of years and destabilize the entire region. What sounds like a cartoon idea quickly becomes one of the most impossible engineering projects ever imagined. The Mediterranean holds more water than humanity could ever hope to move with anything resembling a sink. At best, you'd break physics. At worst, you'd break the planet. So next time you unclog your drain, remember, it may not be seaworthy, but at least it's not collapsing under the weight of 3.7 million cubic kilometers of water.